Hello there everyone, we're going to solve a couple of linear inequalities now. This time we're going to have two inequality signs with an algebraic expression in the middle. Now, to do these, when you have two inequality signs, is to split the problem into two parts really. What shall I do here? I'm going to solve one inequality at a time. So I'm just going to pick this part of the equation first, this inequality first, and just solve it like I would a normal equation. But just notice how I keep the inequality sign consistent in my working. So minus 7 is less than 2x plus 1. So from here I can take 1 from both sides to get minus 8 is less than 2x. And then I can divide both sides by 2 to get x on its own, which is greater than minus 4. Okay, now back to the drawing board where we started. Now I need to do the other half of the problem. So here 2x plus 1 is equal to or less than 14. So again I take 1 from both sides, 13, and then I divide both sides by 2, which is 13 over 2 or 6.5. Okay, nearly there. All I need to do now is write this in set notation. So I'm going to put some brackets here. So x, the inequalities for x are between minus 4 and 13 over 2. So x is greater than minus 4, but it's less than or equal to 13 over 2. Okay, so just recap. I started off with reading the problem first, and then I've split it into two halves. And just notice in my working how I've kept the inequality sign consistent through my working, like so. Okay, and at the end I can put into kind of square brackets it was called the set notation. So the inequalities for x is that x is greater than minus 4, but it is less than or equal to 13 over 2. And if we wanted to check, you could always just use a value for x between these two numbers. So for example, I could say, let's pick an easy one. So x is 0. If I plug 0 into 2x plus 1, I get 2 times 0, which is 0, plus 1 equals 1. Now, is 1 between minus 7 and 14? Yes, it is. Okay, so we know we are correct. Okay, I'm going to do a different one this time. This time, it's going to be, we're going to have another double inequality, but this time we are going to use linear algebra in each part of the inequality. So I'm going to say 2x plus 5 is less than or equal to 5x minus 5, which is less than or equal to 23 minus x. Okay, it's the same process. So you can split the problem in half into two parts if you like. So this time I'm just going to start with that part. 2x plus 5 is less than or equal to 5x minus 5. So I want a positive number of x's on one side, so I'm going to take 2x from over here, but that means I have to take 2x from over here too. So I'm left with 5 is equal to or less than 3x minus 5. And then to make this minus 5 disappear, I add 5, and I add 5 to this side too to keep it in balance. So I've got 10 is less than or equal to 3x but remember we want x on its own. So we need to divide both sides by 3. So 10 over 3 is equal to or less than x. Okay, and if you are not so comfortable with top heavy fractions, you can always change that to a mixed number. So 3 into 10 goes 3 times, 1 left over, and 1/3 left over. So x is greater than or equal to 3 and 1/3. Now on to our second part. So now we're looking at this part here. 5x minus 5 is less than or equal to 23 minus x. Okay, so I want a positive number of x's on one side. So in order to do that, I can get this negative, rid of this negative x by adding 1x to both sides. So I end up with 6x minus 5 is less than or equal to 23. Okay, I need to get rid of this minus 5, so I add 5 to both sides. 6x is less than or equal to 28, because I've added 5 to both sides. Nearly there. So now I need to divide both sides by 6 to get x on its own. So x is less than or equal to 28 over 6. Right, I need to simplify this, because if you notice, our other inequality solution for x is in thirds. So x is less than or equal to 14 over 3. Simplified that by dividing the numerator and denominator by 2. And if you're uncomfortable with top heavy fractions, you can turn that into a mixed number. So 3 into 14 goes 4 times, remainder 2/3. So what we've got here then is set up my brackets to write my set notation. Just move this down a bit. There we go. So x as an inequality is greater than or equal to 10 over 3, but less than or equal to 14 over 3. Now, let's pick a number between there. So we've also got them as mixed numbers as well. So a number between 3 1/3 and 4 2/3. Well, let's pick 4 just to check. So let's say x is 4. Okay. So to check if we are correct, we can now substitute x is 4 back into our original 3 expressions. So x is 4. So let's just do this then. 2 times 4 plus 5 is 13. I'll just write this down. So if x is 4, this expression is equal to 13. If x is 4, 5 times 4 is 20, minus 5 is 15. And if x is 4, 23 minus 4 is 19. So we've proven there that we are spot on, because substituting a number between the two inequalities that we found, it works there when we substitute it back into those 3 algebraic expressions. So just to kind of recap, if you get a double inequality, just do it in 2 different stages, and don't forget to use your set notation. So the inequalities for x is 10 over 3 is less than or equal to x, and x is also less than or equal to 14 over 3. And just to make sure, pick a number that lies between those 2 inequalities and substitute it back into your algebraic expression. Okay, thank you very much.